In this video, I want to have a look at problem solving with trigonometry. So we've learned over the last topic a lot of different rules, the sine rule, cosine rule, area of a triangle, and we've learnt the basic right angle trig of SOHCAHTOA. So it's important that you know when to use each approach. So if we have a right angle triangle, you're most likely going to be using either Pythagoras' theorem or sine, cos, or tan, so SOHCAHTOA. If you've got a problem that involves two sides and two angles of a triangle, that's likely going to be the sine rule. And if you've got a problem that involves all three sides of a triangle and one of its angles, then that's probably going to be the cosine rule. So let's have a look at one example. So our example says the bearing of a lighthouse from a ship is 65 degrees. The ship travels 200 meters due east and the lighthouse is now on a bearing of 23 degrees. And we want to find, for the first part of that question, the distance from the lighthouse to the ship's new position. So the first thing you always want to do is draw a diagram. So let's say our ship is starting over here and our lighthouse is on a bearing of 65 degrees. So that's going to be over this direction somewhere. So we'll draw in our north line. We've got a bearing of 65 degrees is coming over here somewhere. So this is where our lighthouse is. And that means that this angle in here is going to be our 65 degrees. The question then says the ship travels 200 meters due east, so that's going to come this way. So if this is the ship's new position, it's travelled 200 meters. And the lighthouse is now on a bearing of 23 degrees. So we need another north line from that new position. And the lighthouse is on a bearing of 23 degrees now. So that's 23 degrees in there. So the first question is asked us to find the distance from the lighthouse to the ship's new position. So that's the length of this side of the triangle here. So that's x. So that's the distance we're trying to find. Now to do that, we're going to need some angles inside this triangle. So let's try and find this one. If we know that this is 65 degrees and this is coming due east, this whole angle here needs to be 90 degrees. So we can go 90 minus the 65. And that'll tell us that that angle in there is 25 degrees. Now we know that this angle here is 90 as well, because that's a north line and that's the ship's come east. So this whole angle here would be our 90 plus 23, which would give us an angle of 113 degrees. All right, so that's looking a little bit better. It's kind of looking like we're going to be able to use the sine rule because we've got a side here, we're trying to find another side, and we've got two angles. The only problem is, though, we've got the 25 that's opposite our x, so that's good. But the angle that's opposite the 200, which is the other side we know, is this one up here, which is still empty. But that's okay because we can find that. We know that all three angles in a triangle have to add up to 180 degrees. So we would go 180 minus 25 minus 113, and that would tell us that that top angle there is 42 degrees. So now we can use the sine rule to find the length of that side x. So this is part A. So we would have x over sine of its opposite angle, which was its 23, is equal to the other side that we have, so 200, over sine of its opposite angle, which is the 42 that we just found. So now to get x on its own, we'd multiply both sides by that sine 23. So we'd have 200 times sine 23 over sine 42. And if you pop that in your calculator and round to two decimal places, we would end up with, one decimal place, you'd end up with 126.3 meters. So our ship is now 126.3 meters from the lighthouse. Part B of our question asks us how far east the ship still needs to travel before it is due south of the lighthouse. So we want our ship to be due south of our lighthouse. So if we draw a line straight down there, we want to find out how much further east the ship has until it reaches that point. So we want to find this distance here. So let's call that D. All right, so we do know x, we just found that in part A, and I've just written it up here. We've got a right angled triangle, so that should point us in the direction of trying to use sine, cos, or tan, or SOHCAHTOA. So we know the length of this side here, that's what we just found. We're trying to find this side, and we need another angle in the triangle. So we know down here that the ship's continuing in the same direction, So that there needs to be a straight line, which means it has to be 180 degrees. We already know that this part here is 113 degrees, so that means that this bit here would be 180 minus 113, which would give us 67 degrees. Right, so we've got our angle, we've got one side and we've got another. From that 67 degrees, our D is our adjacent side, and that X length there is the hypotenuse. So adjacent and hypotenuse is going to be cos. So we know that cos theta is equal to the adjacent side over the hypotenuse. So in our triangle, we're going to have cos of 67 degrees is equal to D over 126.3. Then to get the D on its own, we're going to multiply both sides by 126.3. So we'd have D is equal to 126.3 times cos of 67 degrees. And if we round that answer to one decimal place after we've put it in our calculator, we should end up with 49.3. So it needs to travel another 49.3 metres before it is due south of the lighthouse. Right, so that's one example of how we can solve problems using trigonometry.